graphs. So when you take a look at this particular graph, and suppose I want to know what happens as we approach 1 from the left. So what you're going to do is, again, you're going to find 1. Here's 1 on my x-axis. You're going to take your pencil, and you're going to go, in this particular case, I'm going to go to the left of 1. So I'm just going to take my pencil, put it on my graph to the left of 1. Trace it. So as I'm approaching 1 from the left, I'm hitting 1. What y value am I getting really close to the left of 1? I'm getting really, really close to what's the y value of that particular point?
4.
-4. So now, instead of coming from the left, let's go from the right. So again, find 1 on your x-axis, take your pencil, and go to the right of 1. Now trace your graph and approach 1 from the right. What y value are we getting really close to? We're getting really close to what y value? 2. What you've just found are the limits from the left and the limit from the right. All right, so that's exactly what a limit is. So when we talk about a one-sided limit, we're looking at the limit as you're approaching a particular value from the right, like we just did in Part B. And the limit notation that we use, you'll see limit abbreviated as LIM. Underneath limit, you're going to see this subscript as x approaching some number, which I'll call C. And to indicate from the right, you're going to see a plus. So this plus right here means that you're approaching that particular x value from the right. So for example, up here in Part B, we would write this as the limit as x approaches 1 from the right. And again, you always identify the function. So you can write out the equation or just write out f of x. So that's what you just found in Part B. So again, when you see this plus exponent, that means that you're coming from the right. So another one-sided limit when you're coming from the left, like we did in Part A. So when we're coming from the left, again, you're still going to see the limit abbreviated as LIM. You're going to see x, and you're going to see that arrow. That arrow means you're approaching some particular x value. And again, to show that you're coming from the left, you'll see a negative exponent. So this negative exponent right here means you're coming from the left. So for example, up here in Part A, when I asked you to find what happens as the graph approaches 1 from the left, you actually found the limit from the left. So the notation you would see is the limit as x approaches 1, and you would see a negative exponent for 1, and then f of x. So that's what a one-sided limit is. A one-sided limit, you're going to see with the number after the arrow, you're going to see a plus or a minus as the exponent for that particular number. Yes, it's always going to be a y value when you're finding the limits, yes. So what happens is with the limit notation, you'll see the x with the arrow. So that's telling you what the x value is. What you're solving for is what y value you're getting really close to. So again, if you take your pencil, go to the right of 1. So you have to take your pencil and slide it so that you're on the graph. And then you want to approach 1, but you're on the right-hand side of 1, which is right here. Okay? So those are one-sided limits. You also have what are called two-sided limits. A two-sided limit is if you have the same one-sided limit to the left and the right. Then the two-sided limit exists. So for example, notice here's a particular x value at A. Notice what happens on the left. You are approaching that particular point. What happens on the right? You are approaching it. So what happens for a two-sided limit to exist? The limit as x approaches A from the right has to be equal to the limit as x approaches A from the left. So that's what a two-sided limit is. So what happens on the right of a x value has to be exactly the same value from the left. So for example, in the example that I did up here in A and B, the two-sided limit would not exist because what happened on the left was a different value than what's happened on the right. So the two-sided limit does not exist. So you have to find what's happening on the left and the right and see if there's the same for a two-sided limit to exist. Okay? So this is where we're going to use the calculator. So there's 3 different ways that you have to be able to find limits. We did a brief graph, so you're going to have to use graphs. You're going to have to use tables and algebraic ways to find limits. So this is the one way where we're going to use the tables. So for example, let's take a look at this particular table. Now one thing, let me go back, I'm sorry, I should have added this. When we talk about limits from the right, we're looking at x values that are slightly larger. We use that phrase from the right, but if you look at your graph, x values to the right of 1 are actually larger. For example, 1.1, 1.2, 1.3, 1.4. So all of your x values to the right are slightly larger. When we talk about from the left, we're looking at x values that are slightly smaller. So if you look at your graph, when I go to the left of 1, when I put my pencil to the left of 1, I'm looking at x values smaller than 1. For example, 0.9, 0.999, 0, etc. So when I say from the left, you're looking at x values smaller. When you say from the right, you're looking at x values larger. So let's talk about how you can find limits from the table. So first of all, because I see x is approaching 3 with the plus sign, is that from the right or from the left? From the right. This is from the right, which means I'm looking at x values that are slightly larger. So when you're trying to find a limit using a table, in this particular case, the x values are filled out for you. You're trying to find the y values for x values that are slightly larger than 3, not at 3. Again, limits, I don't care about what's happening at x equals 3. I want to know about the behavior around 3. So what's happening slightly larger than 3? So notice in my x values, I got 3.1. Pretty close to 3 without being equal to 3. You agree with that? 3.01. It's even closer to 3 without being equal to 3. You agree with that? 3.001. Pretty close to 3, but notice I'm not equal to 3. 3.00001. Really close to 3, but not equal to 3. That's what a limit is. I don't care about what's happening when x equals 3. I want to know about what's happening, the behavior around x equals 3. That's what a limit is. All right, so now on your calculators to help you out, if you go to your table set, go to your second window. Right now, under second window, your independent variable is automatically defaulted to auto. What you want to do is you want to change it to ask. So arrow down and just click on ask for your independent. Remember, your independent variable is x. So that's what I mean under these direction here. Change your table setup to independent. Remember, you go under second window to change your table setup. Now the reason why you do that is because these are a whole bunch of decimals. So the quickest, easiest way to use your calculator to find the outputs for these different decimals, go under your y equals. I want to find the limit as x is approaching 3 from the right of the square root of x minus 3 plus 1. So I'm going to simply type in that function, x minus 3. And make sure, again, guys, be careful that plus 1 is on the outside of the radical. Okay. Now, if I go under my second graph, which is where my table of values is, when you change that independent variable to ask, it clears out your table of values. It's not automatically, when you had it on auto, the calculator was automatically filling in x for you and then calculating y values. So the calculator is now waiting for you to type in an x value. So if I type in 3.1 and hit enter, notice it's giving me my y value 3.4698. Oh, I hit x plus 3 instead of x minus 3. Thank you. 1.3162? Yeah, it helps if I type in the right function. Okay? So now I can type in 3.01. And notice when I type in 3.01, I get a y value of 1.1. So now when I type in 3.001, I get 1.0316. Yes, Sophia?
My calculator's not giving me. It's like really close to it, but it's not the exact one.
Okay, let me take a look at it in a second. Then I type in 3.1231. I end up with 1.01. So notice, guys, what's happening. I'm still looking at x values that are larger than 3, but I'm not equal to 3. What does appear as I'm getting closer and closer to 3? What y value does it appear I'm getting really close to? 1. So there's the limit. And I bet you if I even pull this closer, like for example 3.000001, notice that's really close to 3, but I'm still not equal to 3. Notice I get 1.00001. So notice that's what's happening. So when you see that table, again, when I come from the right, all these x values have to be slightly larger without being equal. The closer I got to 3, it appears the limit is approaching 1. So any questions on that? So let's look at number 5. Again, I have that plus exponent. So what side am I coming from, the left or the right? To the right. So I want to look at x values that are slightly larger than 0. So if you look at my table, you see I filled out x values that are slightly larger than 0. 0.1, 0.01, 0.001, 0.00001. All are x values slightly larger than 0, but not equal to 0. So again, I can use my calculator, go back to your y equals. Now I'm typing in a fraction, so again I'm going to do my x minus 2. Make sure you have parentheses around that x minus 2, or use your fraction bar, divided by x. Oops, I hit graph by accident. Again, if you want to clear out those x values that you've already typed in, just hit delete. Just hit delete it on those x values and it'll wipe out the x values you've already typed in.
You don't say clear, right?
No, if you want to clear the table, you hit delete on top of it, yeah. So now if I type in 0.1, that gives me negative 19. 0.01, negative 199. 0.001, negative 1,999. And then I end up with negative 19,999. So that's interesting. As I got closer and closer to 0 from the right, do you notice a pattern? Am I approaching a particular number? I mean, it looks like, but notice if I probably went out further, it's not. What's happening with the behavior? It's approaching what? It's not approaching a number, but what's happening? These numbers are getting really, really small, aren't they? So it looks like it's approaching what? Negative infinity, exactly. Now, why is that happening? Because even if I typed in, let's say, 0.00001, notice that's even a bigger number. That's scientific notation. So it's not approaching. So not all limits are going to approach a number. Some may approach positive infinity or negative infinity. What's happening graphically at x equals 0? Is this defined? What happens if I plug 0 into this fraction for x? It's undefined. Why is it undefined? Can't divide by 0. So note if I try typing in 0 on my calculator, notice I'm getting an error message. But even though I plugged in numbers that were really, really close to 0 without being equal to it, I was getting outputs. So graphically what's happening is you have a vertical asymptote. And if you look at your graph, as I'm approaching 0 from the right, you can see the behavior of the graph is going down towards negative infinity. So that even though the defined value is undefined, notice even though I plugged in numbers really close to 0, I was getting a value out. You guys go ahead and try 6 for me. So what y value, as you filled in your table, what y value does it appear that you're getting really close to? 5, exactly. And what is f of 1? What does this notation mean? This means when x is equal to 1. So when x is equal to 1, what is your exact y value going to be? 5. So there are times when limits are going to be the same as the defined value as you have in this particular case. But as you saw in the other examples, that wasn't necessarily the case. All right? So when the limit is exactly the same as the defined value, you can find limits using what we call direct substitution. So the way you solve a limit is by direct substitution. So now we're going to move away from tables and talk about algebraically how you can find limits. And it doesn't matter whether you're coming from the right or coming from the left. All you're going to do is you're going to let x be equal to c. Okay? If you get an answer, you found the limit, you're done. So for example, to find the limit as x approaches 1, and again it's from the right, I'm always going to try algebraically and find limits by direct substitution. So what I'm going to do is I'm simply going to let x be equal to 1. And I'm going to plug in 1 for x. And what is 1 minus 5?
4.
Negative 4, you're done. So this is a case where the limit is exactly the same as the defined value. Again, it doesn't matter if you're coming from the right. For direct substitution, algebraically to find limits, you can just plug it in.
Wait, how do you know that's the limit?
Because it's asking you to find the limit as x approaches 1.
Oh.
When this only works if the defined value is the same as the limit, which it is in this case. If it doesn't, if the limits are different, then direct substitution doesn't work, and there's other ways you're going to have to find the limits algebraically. Yes, Sophia?
How are you supposed to know if it is or isn't?
If you get an answer, it is.
Okay.
Yeah, if you get an answer, you found the limit. Okay?
So if
So
there's like no answer, it's like if it's like
there may be other stuff you'll have to, there's other algebraic methods you can use. But direct substitution, you always try direct substitution first, because if you get a number out, you're done. You found the limit. So for this case, again, limit as x approaches 1 from the left. All I'm going to do is I'm going to plug in 1 for x. Again, it doesn't matter if you're coming from the left or from the right. If you want to find limits with direct substitution, just plug in the 1. So 3 times 1 to the third plus 4 times 1. Do you get an answer? What's the answer? 7. So you know the limit exists, and you know it's 7, you're done. No, no. Remember, this negative sign has nothing to do with whether it's all that negative exponent means. What does it mean? You're coming from the right or you're coming from the left. Doesn't mean that one is negative or positive. Okay? Trig. Oh my gosh, I thought we were done with trig. Limit as x approaches pi over 4 of sine x. So what we're going to do is we're simply going to let x be equal to pi over 4. So I'm going to plug in pi over 4 for x. Unit circle, so what's that sine of pi over 4? Square root 2 over 2. That's just your answer. Like I said, we'll study other ways to find limits when the defined value is not equal to the limit. There's other algebra techniques that we'll talk about when this doesn't work. Okay? So what are you going to do at 12? You're simply going to let x be equal to what? 0. So 0 squared minus 4 over 0 minus 2 is going to give me what? Just 2. You guys go ahead and do the last 2 for me. So did we come up with 6 for 13 and 2 for 14? Okay? Like I said, there's 3 ways you have to do limits: tables, algebraically and from graphs. So again, we did tables, and again, there's other algebraic methods we'll study later on this semester. For right now, all I'm asking you to do algebraically is direct substitution. Direct substitution only works when defined values, it's the same as the limit. All right? So what we're going to concentrate on now is just graphs. Again, when we talk about the limit, if you get arbitrarily close to a number as you approach C from either side, and again, when you have a two-sided limit, remember you're not going to see that plus or minus exponent with that x approaches that particular number. So this is what's called that two-sided limit. Like I said, you're going to see all kinds of crazy graphs. Let's take a look at graph A. So it says the limit as x approaches -1. What does that plus sign mean? That plus sign means we're coming from the what? Right. So again, what you want to do is you want to find -1 on your x-axis. You want to take your pencil and place it to the right of -1. And place your pencil on the graph to the right of -1. Trace your graph till you get really close to -1. So when I approach -1 from the right, what y value am I getting really close to? I'm getting really close to what y value? 2. Let's look at B. The limit as x approaches -1. What does this negative exponent mean? Left. So again, I want to take my pen or pencil, go to the left of -1 on the x-axis. So place my pencil wherever my graph is to the left of -1. Trace your graph till you get really close to -1, but you're on the left-hand side. So again, as I approach -1 from the left-hand side, what y value am I getting really close to? I'm getting really close to what? -2. So any questions on A or B? Yes?
So there'll always be like these weird lines on the
A lot of
graph?
times for graphs, yes.
Okay. So like that's how you know which way to go.
Well, depending, it's going to change from graph to graph. Again, you just have to go to the right or go to the left. Because again, to the right, if I take my pencil and I go to the right, you want to get really close to -1, but you need to be on the right-hand side of wherever x equals -1 is. And look at that y value. Now, this is a two-sided limit. Because notice you do not have a plus or minus exponent for -1. So in order for this limit to exist, the limit as x approaches -1 from the right has to be equal to the limit as x approaches -1 from the left. So I found the limit from the right. I found the limit from the left. Are they the same number? No. So it does not exist. The two-sided limit does not exist. You can abbreviate it as a D&E. So when you find what's happening on the left and the right, if they're the same number, then the two-sided limit exists. This is the only way. So this is called, what has to happen is the behavior on the left has to be the same as what's happening on the right. Let's look at D. Is this a one-sided or two-sided limit? How do you know it's a two-sided limit? There's no plus or minus exponent. So you have to find the limit as x approaches 3 from the right, and it has to be equal to the limit as x approaches 3 from the left. So you have to understand, to find a two-sided limit, what's happening on the left and the right has to be the same number in order for this two-sided limit to exist. So you want to find 3 on your x-axis. Remember, it's not asking about what x is equal to. I'm going to take my finger, I'm going to go to the left of 3. I'm going to take my finger, I'm going to go to the right of 3. Again, I want to be on the graph, and again, as I'm getting closer and closer to 3, what y value am I getting really close to? I'm getting really close to what y value? 3. Okay. Take a look at E. Is this a one-sided or two-sided limit?
Two-sided.
Two-sided. So the limit as x approaches -4 from the right has to be equal to the limit as x approaches negative 4 from the left. So find negative 4 on your x-axis. So I'm going to take my finger and I'm going to go to the left of negative 4. Take my finger, go to the right of negative 4. I'm going to trace my graph and see what happens as my fingers start to meet. What y value am I getting really close to? I'm getting really close to what y value? Negative 5. Okay? Any questions on that one? What's F asking me for? So when x equals negative 1, I want the actual defined value. What is y equal to? I'm not concerned about the behavior. So look at x equals negative 1. What's the difference between the open and closed circle in this graph? What's the difference? It's included or not included. So when I talk about what it's equal to, I want to be looking at the closed circle. So when x is equal to negative 1, what is the defined value? The defined value is what? 2. What about f of 3? So when x equals 3, what's the y value? 5. Okay?
What is that hollow circle?
I'm sorry?
What is that hollow circle?
Maybe that's just a boundary marker. So basically, if I want to know what negative 1.001 is, again, you're getting really close to negative 1 from the left, but it's not equal to negative 1 right there. Remember, it's just a boundary point. It's not what it's equal to. Yes, Chad?